Okay, good morning everyone. This is our topper. We're going to discuss about conic sections. A conic section is the intersection of a plane and a right circular cone with two napes. So here is the figure. As you can see, there are two bases at the top and the bottom. This is the x-axis. This is the generators. This is the so-called upper nape, the lower nape, and also these are the generators. And the intersection of the two nape is called vertex. In this chapter, we shall consider the curve of intersection of a plane and a right circular cone, one with an axis that is perpendicular to the base of the cone. These plane curves are called conics, so named because each of them is a section of the conical surface made by a plane. A line lying entirely on the cone is called a generator, or element of the cone, and all the generators of a cone pass through its vertex, which is the only point where the two napes intersect. There are basically two types of conics, the degenerate and a non-degenerate. A degenerate conic is either a point, a circle, a line, or two intersecting lines. A non-degenerate conic is either a parabola, an ellipse, or a hyperbola. These non-degenerate conics can be characterized by the number of generators which are parallel to a cutting plane. Let's proceed with the first one, circle. Circle is defined as the set of all points on the plane that are equidistant from a fixed point on the plane. The fixed point is called the center, and the distance from the center to any point of the circle is called the radius. So there is a standard equation of a circle. Number 1, a circle with radius r and the center hk. So this is the equation. The square of x minus h plus y minus k squared is equal to square of r, where r is greater than 0. Number 2, a circle with radius r at the center 0, 0. So we have this equation, x squared plus y squared is equal to r squared, where r also is greater than 0. So here is the illustration. The point on the circle P with x and y points, and the center has hk, and this line is called the radius. These are the basic parts of a circle. Let's have the example 1. Find the equation of a circle with radius 4 and the center at negative 3, 6 and b 0, 0. Let's have the solution. At center at negative 3, 6, we use the formula. The square of x minus h plus the square of y minus k is equal to the square of 4. 4 is the radius. And by substitution, we have as h equal to negative 3, so it will become x plus 3. Then 6 is positive, so just substitute it with k, so it is y minus 6. Then squaring 4, we have 16. And finally, we have the square of x plus 3 plus the square of y minus 6 equals 16. How about center at 0, 0? So very easy. So we're just going to have x squared plus y squared and the radius 4, substitute it, so it will become x squared plus y squared equals 16. Okay, can you follow? Let's proceed. Example number 2. Find the equation of a circle of radius 4 which is centered at 3, negative 2 in its general form. So first, we express that in this standard form. So the square of x minus 3 plus the square of y plus 2 equals 16. So 16 from 4 squared. And simplify further by squaring the binomial. So we have square of x minus 3 is equal to x squared minus 6x plus 9. Copy the sign plus. And the square of y plus 2 equals y squared plus 4y plus 4. And copy 16. And doing this one, combining like terms, we have x squared minus 6x plus y squared plus 4y plus 13 from 9 plus 4. Okay, simplify further. We need to rearrange. The first and second must have the exponent 2. So we have x squared plus y squared minus 6x plus 4y minus 3 from 16 and 13. So if you transpose 16 from the right to the left, it will become negative 16. So therefore, 13 minus 16 is negative 3. So that is the equation. So let us discuss what do we mean by general form of the equation of the circle. So the general form of the equation of the circle is given by x squared plus y squared plus dx plus ey plus f equals 0. So remember that. Whatever is the coefficient of x, that is representing capital G. And whatever number beside y rather represents e. And whatever constant is given, it is f. Okay, can you follow? So let's have this class enhancement. Write the equation of the circle with the radius (3) and center 0, 0, and also with the center at 3, negative 2, and r equals 1. For number 2, find the equation of the circle in its general form. So let's have the solution. For number 1, where c or the center is 0, 0, and the radius is 3, we simply use this one by substitution. We just substitute the value of r as 3, and then copy x squared plus y squared on the left side. So we landed with x squared plus y squared equals 9. If the center is at 3, negative 2, and with radius equals 1, we use the standard form, the square of x minus h plus the square of y minus k equals r squared. And by purely substitution, we have x minus 3 squared plus y plus 2 squared equals 1 squared. Simplify further, and by squaring the binomial, okay, we have this. Okay, so we have the square of x minus 3 plus the square of y plus 2 equals 1. Okay, for the last one, we have center at negative 4, 2, and the radius is 5. We simply first use the standard form, the square of x minus h plus the square of y minus k equals r squared. And using this, substitute that, it will become x plus 4 squared plus y minus 2 squared, and then radius 5 squared. And by squaring binomial, we have x squared, 2 times 4 times x is 8x, and 4 times 4 is 16. Copy the sign. And then y squared, 2 times negative 2 plus times y is negative 4y. Then plus negative 2 times negative 2 is positive 4. Then 5 squared is 25. Simplify further, regroup. It will become x squared, y squared, plus 8x minus 4y. Then 16 plus 4 minus 25. Transpose 25 from right to left. It will become negative. So equals 0. Okay, to polish this one, we have x squared plus y squared plus 8x minus 4y minus 5 equals 0. So this is the final answer. And again, thank you for listening and good morning.